Hello, my name's Julian Edgar and I'm the author of the book Car Electrical and Electronic Systems. What I want to do in today's video is talk about relays. Now, a relay is just a switch that's switched remotely. It uses an electromagnet inside to pull across the contacts. That's all it is. So let's have a look inside and let's have a look at how they're described and how you can think about them. So what I've got here is a schematic diagram of a relay. The C is the electrical coil. That's the thing that triggers the electromagnet. So if we feed power to the coil, it becomes a magnet. Now what does that magnet do? Well, it closes this switch. Now have a look at how I've drawn it. I've drawn it so if you can think of the coil suddenly producing a magnetic field, you can see it pulls the switch up. And that's a good way of drawing it, because if you turn off the power to the coil, you can see that the switch just drops out, as if by gravity. We know it's not. We know the real relay is springs doing it, but when we picture it in our minds and when we picture it in circuit diagrams, that's a really good way of showing it. So draw it so the switch actually drops out when the coil turns off. Now, when you have a look at a relay, you'll see quite a lot of contacts on some of them. So firstly, we've got two contacts for the coil, those two contacts. And then in this case, we've got one contact for the switch and then a second contact for the switch. But some relays have three contacts for the switch. Now, how does that work? Well, let's add a contact there. Now, you can see that when the relay is switched off, when there's no power going to the coil, the power can go through these contacts here. When you turn on the coil, put power to the coil, you can see the contact gets pulled up and now it goes to the other terminal. So it's called a changeover relay because it can change from one circuit to the other. Now, here's where some people get confused as to the nomenclature, the names that are used for the different terminals on the relay. So this one is called a common, this one is called normally closed, and this one is called normally open. Now have a look at why that's the case. Normally closed, it means it's connected when there's no power going to the coil. But you can see the other one in that situation is open, so it's called normally open. When power is applied to the coil, it pulls the contact across from the normally closed to the normally open one. Now, if you've got a relay and you're a bit uncertain as to what all the terminals do, you can use your multimeter. You can use a multimeter and there'll be a resistance, say 100 ohms, 200 ohms, depending on the relay, across the coil contacts. Whereas here, this will have continuity because of course it's connected when there's no power going to the relay. This one won't have continuity, but when you apply power to the coil, suddenly you'll be able to measure continuity across the normally open one. So, let's have a look at those terminals again. Two for the coil, a common for the switch, normally closed, normally open, and many relays don't even have that. So they just have a normally open terminal in that way. Relays are great fun to use. You can achieve a lot with them, and not just horn relays and headlight relays. In electronic circuits you can achieve a lot with them, switching signals. So don't just think that relays are for big power circuits. They can also be used for switching signals and achieve really good outcomes. The book's called Car Electrical and Electronic Systems. I cover relays and they're very close cousin switches in that book, and I recommend it to you. Thank you.